Hey, what's up? On this episode of Cribs, I'm going to be showing you my house. Just kidding. I have to bring you day 68 from my house because we are in the middle of a polar vortex. So, today we're looking at day 68, indefinite integrals, and we're going to talk about integrals as antiderivatives. So, I'm going to start here with just some very simple review of the power rule of derivatives, right? So if we have a function x cubed and we want to do the derivative of x cubed, we know that that's just going to, sorry if this camera's a little shaky, I'm doing the best I can here. The derivative of x cubed would be 3x squared, okay? But the interesting thing about derivatives is that when we do the derivative of a constant, it ends up being 0, right? So the derivative of x cubed plus 5 would also be 3x squared. Now that didn't really present a problem to us when we were doing derivatives. However, it's something we have to consider if we're doing antiderivatives, right? If we're going backwards. Because take a look, 3x squared, if I do the antiderivative, right? I could get x cubed, or I could get x cubed plus 5, or I could get x cubed plus 10, right? No matter what, I could always add on some kind of constant. So that's something that we'll have to keep in mind as we do our antiderivatives. Okay, I also talked about indefinite integrals. That's all an indefinite integral is, or that's how we're going to look at it right now. It's just an antiderivative. Okay, so and we're going to come up with a power rule for this, and that's all we're going to look at today is polynomials. But stay tuned at the end of the video. I have a special guest appearance, and I'm going to provide for some of you guys what you've been waiting for all year. So get ready for that. Stay tuned to the end of the video. Okay, so let's try an integral. Okay, so here, this is an indefinite integral. We can tell because there are no numbers at the top and bottom of our big S for integration. So what I want us to do is think about, well, what would be the answer to this antiderivative? What function, if I took its derivative, would end up being 6x squared? Well, one thing we have to consider here is when we do derivatives of power, right, x to a power, we always end up reducing the power by 1, right? X cubed became 3x squared. So we know that our function is going to be something x cubed, right? X cubed itself isn't going to work because the derivative of x cubed ends up being 3x squared. So what's going to have to be the coefficient for this thing to work? Well, whatever it is times 3 has to equal 6. So you could say, okay, well that's got to be maybe 2x cubed. And we can always stop. One of the tricks that I want you to get the hang of is anytime you're doing an antiderivative, right, go ahead and check this by doing the derivative to make sure it gives you this. Well, the derivative of 2x cubed would be 6x squared, okay? But I have to account for the fact that I could have some other constant added to this, right? It could be 2x cubed, it could be 2x cubed plus 1, it could be 2x cubed plus 10. It could be literally any constant attached. It could be 2x cubed plus pi. So to account for that, when we solve these indefinite integrals, we're going to write 2x cubed plus c. Now, I want to try a different one. Let's take a look at this one. Okay, so now I want to integrate, find an antiderivative for 7x to the 5th dx. Okay, so what I want us to think about is, what would be our power of our antiderivative? Well, the derivative's power would be to the fourth, right? Derivatives always knock the power down by 1. But this power is going to be bumped up, right? And it's going to be bumped up, so I know it's going to be something x to the 6th. Okay. But what am I going to have to, what's going to be my coefficient so that when I multiply it by 6, I end up with 7? This is where it gets kind of weird, right? We have to think about what number would that be. Obviously, it's not going to be an integer. Okay. So what number would that be? Well, I want to end up with 7 as an answer. So what I'm going to do is I'm going to put 7 on top, and I want to cancel that 6 out by putting 6 on the bottom. And I get 7x to the 6th plus c. Now, if I do the derivative here, when I multiply the 6 out front, the 6's will cancel, and I'll be left with 7x to the 5th. Okay, the plus c accounts for those constants in there. Okay. Well, let's come up with a rule so we can do this faster, so we don't have to think this thing through every time. Okay? And I call this the power rule, right? And I'm going to call it bump and divide. So, let's try a general. So, let's look at the integral of ax to the n dx, right? So just some coefficient times x to a power. Okay. Well, what this is going to be every single time, right, is we know we're always going to bump the power